A buffer solution is prepared with 0.20 ammonia, NH3, and 0.30 molarity ammonium chloride. Hint, hint, hint. NH4 is in parentheses for a reason. The measured pH is 9.26. Find the pKb for ammonia. All right, so what do we have to do with this problem? What do you think we have to do? Well, again, if we go back to our formula, we know that the pH formula is equal to pKa plus the log of your conjugate base divided by your weak acid, right? We know this part. We also need to know this other thing. Remember how I put Kw is equal to 1.0 times 10 to the 14th? Remember when I put that up there? Well, that was for a reason. Because just like Kw is equal to 1.0 times 10 to the negative 14, well, guess what? pKa plus pKb also equals 14. Now, keep this in mind because we are going to redo this formula right here. Okay? We're going to redo this formula like we did previously, where we're solving for the pKa first, work backwards, and then plug it in to this formula down here. All right? I'm going to write that formula again to find the pKa, okay? So pKa is equal to pH minus the log of A over HA. All right, now remember what I said, the hint that I gave you earlier. Look at the one with hydrogen versus the one that had the hydrogen removed. That tells you what numbers go where, all right? So you have NH3, so that I don't have to keep pulling the screen down. I'm just going to do it like this. And then the one that had NH4 with it, okay? That was that number right there. All right, so what numbers go where? You've got to figure out where to plug them in, okay? Hey, Monica, I went live at 12:04. Yep, 12:04. All right, so it's okay. This will be on my YouTube channel, so you can get it there. Yep, this will be on my YouTube, so no worries, no worries. So you're going to say pKa equals, oh, and let me put over here so I don't have to keep pulling the screen down. The pH was, I think, 9.26. Yep, 9.26. All right, we need these three numbers here for this problem. So pH 9.26 minus the log of, so what's going to go on the very top? The 0.20. And on the bottom, 0.30. All right. So now divide these two numbers first. Before you do anything else, divide those two numbers first. So you've got 0.2 divided by 0.3. You get 0.66666, basically 0.67. All right. So your pKa is equal to 9.26 minus the log of 0.67. All right. Now, you know we got to take the log of that, right? Which gives us 0.18. So 9.26 minus 0.18. And actually add those two together. And you know why? Because the negative log of that number right here, when we plug this into our calculator, the 0.67, it was minus, and then because you have a minus sign right here, you're going to add them together. And so 9.26 plus 0.18 gives us 9.44, okay? So the pKa is equal to 9.44. Now, what are you going to do here? We're trying to solve for the pKb. Remember that, right? We're solving for the pKb. So we're going to go back to equation number 2 right here, and we're going to plug it in. We're going to plug in the pKa that we just found, all right? So remember, pKa plus pKb equals 14. Well, we're trying to look for pKb. So that's going to equal to 14 minus 9.44. And you get 4.56 as your pKb. Okay?